Hi, this is Sam Wilker with thinkparticle.com, coming at you with another tutorial today. And today we are going to have some fun. This is the 35th tutorial for our website, and we are going to talk about making Mandelbulb Fractals in Cinema 4D with Krakatoa. This is an awesome tutorial, this is an awesome technique that a friend of mine named Pingo, which is the creator of the C4D Advanced Production Techniques 1 and 2 series, which if you haven't seen yet, go check that out on Vimeo. I'll link it in the description. He sent me a link to this tutorial for, I think it's 3ds Max and V-Ray, how to make fractals with 3ds Max and V-Ray with these different softwares, which I'll show you how to get. And then he did that too with Arnold for the Cinema 4D Advanced Production Techniques too. So if we look at that real quick, just a quick shout out to him because, well, first of all, he deserves it. Second of all, you should check it out anyways. This is a fantastic project. So that right there, if we just go back very quickly, this is rendered with Arnold. And his is, I believe, geometry. So we aren't going to be rendering geometry. We're going to be rendering particles in this case, but I'll show you how to get that direction. And then go ahead and check out his Arnold tutorials in C4D Advanced Production Techniques 2 as well. If you purchase it, it's only $100, and you get training from some of the world's greatest animators around the planet. So definitely recommend it. Anyways, go ahead and check that out. So next, this is going to be linked in the description, but we're going to go over everything that this talks about. So the first thing you need to do is go to mandelbulb.com and make sure you download the 3D software. So this is where you can download, when you Google it, it's actually the first result. You just Google Mandelbulb 3D, and you need to download either Windows or Mac version, depending on what software you're running. The next is a software called Fiji. So go ahead and go to fiji.sc/Fiji with a capital F, and make sure you download that as well. And there's a lot of different versions here. Again, OS 10 and Windows. And the last one is MeshLab. I don't know if this is absolutely necessary, but I did have to use it today. And again, this works on Mac and Windows, and I think actually all of these, technically speaking, no, Mandelbulb 3D does not work on Linux, so scratch that. But anyways, it's a really cool technique used in Big Hero 6, and it's the only other big production I've ever seen a Mandelbulb in. But they're beautiful. And we're going to make some. This is rendered with volumetrics, so it's a little different than this. But we'll go ahead and just get started. So the first thing I'm going to show you is the scene that I've built, just for the geeking out portion of it. I'm going to show you that I've imported a Mandelbulb object right here, and I'm using a matrix object to clone thinking particles to it. And after doing that, I use some custom espresso nodes right here, which I'll show you how to set up after we build our Mandelbulb, to apply the age of a particle based on the distance from an object. And that way I can have some extra added control over how I render it graphically with Krakatoa. So let's go ahead and wait for this to load. One thing you'll notice right there is there's 2,132,984 particles. That's a lot of particles. And when you run an espresso system like this on every particle, it takes a little while. So we have to wait for the particles to load. Then we have to wait for the age by distance setup that I've built to load. So and then you get things like this, which look pretty cool. At least I think so. It's pretty nice. So, and then without using the Mandelbulb, we can actually also use this sphere, which I built so I could actually test the settings a little bit easier. Let's go ahead and grab the distance checker. We're going to move it over here. And then update, and we need to make sure we have all of our particles. It only loaded 44,000. Okay, I think it's loading all of them. Maybe not. There you go. Okay. So again, that works. One thing we can do is we can turn off the absorption gradient, and I'll show you how to do that again. So now you can tell there's a gradient here. It's greener over here and browner over here. I actually like some of these more though, so I'm gonna grab this and paste it. Colors are kind of gross, so let's go ahead and fix that color. Get it to a nice turquoise. There you go. Maybe not enough contrast there though. Let's get some blue. So this will show you. Okay, so basically this distance checker is, it's actually a really harsh fall off at the edge. That might just be the lighting, but I'll go ahead and show you how to build that. But again, let's go ahead and first let's make our Mandelbulb. So what we're actually going to do is just close Cinema 4D, and we're going to open up this Mandelbulb 3D software once you've downloaded it. And I actually just calculated this right here, my first Mandelbulb. So what you can do is you can go into Mandelbulb 3D and go ahead and go to their website, and you can learn a lot more about how to use it. But there's a lot of Mandelbulbs in here. You can go ahead to this formulas tab over here, and you can pick different formulas from these drop downs. And let's pick one. Let's try the octococh, or let's see. And then to zoom out, let's see. I'm not entirely sure how to use this perfectly yet. Okay, there we go. So to zoom out, you gotta right click, and then you can render. So let's go ahead and use something like that for this example. This is an incredibly complicated fractal, and it looks really cool. The only problem is I do want to make sure it doesn't get overly complicated, so keep that in mind. We're going to just change the image width and height to 600 by 600 for the moment. Actually, we'll do 512 by 512. So we'll just drag this and center it. And then we'll right click again and again and zoom out, and one more time. And then we'll calculate in 3D. Okay, we've got it. Good. Now we need to go to utilities, and we're going to click voxel stack. Then we're going to go to preview max size and hit 256. And what it's going to do is it's going to build a, oh gosh, I can't remember what that's called. It's how they scan brains. It's a cross section, a cross cut of, it's 256 cross-section cuts of the Mandelbulb fractal. So in this tutorial online, they recommend staying between 512 and 1024 for the fractal size. This is only 256 right here, so I'm going to keep it at 512 because there's a technique that he uses for decimating the mesh. We're not going to do that. We're going to keep every point, and that's going to get heavy. So let's go ahead and save this. We're going to select the output folder. And we're going to go to Think Particle for me and Tutorials, and we're going to go to Mandelbulb 3D Krakatoa. We'll just do that. And then we're going to output this in a folder, a custom folder. Make your own folder for this output right here, because it's going to be one image for every crosscut, so 512 images. And this is going to be called the Mandelbulb voxel stack. You can name it whatever you'd like, but that's the technical term. So Mandelbulb voxel stack. And what I like to do is, because the software's a little buggy, I'll copy that, and then I'll just make sure I do my testing right here. And I'll test all the software and see if there's anything I want to change. I definitely want to keep it to distance estimation, and we'll go with outside. And again, like I said, this will change. So we'll paste that, and then we're going to type or click Start Rendering Slices. And it's just going to go ahead and start rendering these out. And as you can see right here, this is the cross section. So it's really cool because it's actually very similar to, again, like I said, how brains get scanned. I can't, I only slept 3 hours last night. Really can't remember any technical terms right now. But I know how to animate, so we're good. Yep. Anyways, I'm going to pause while this finishes. Actually, no, I'm not, because it's almost done. Okay, cool. So we're done with that. So we're going to close that and then exit out of this. The next is to open the Fiji software. So once you've downloaded that and installed it, go ahead and open this up. And then you're going to do click File, Import Image Sequence. Okay, this is a really interesting software. I've never really seen anything like Fiji before, but I definitely like that it exists. It's very useful. You can use images to generate 3D objects, and then a bunch of other things. It's built in Java. It's very powerful. So go ahead and see what else you can do with it. It's exciting. So we're going to go ahead and just select the first image in this sequence, and then the only other thing is to click Use Virtual Stack, and we're going to just drag through, make sure we're good. Yep, that's the one we were looking for. We're going to click Save As, and then just save it as a wavefront. In his tutorial, he saves it as a, I think it was called a PNM file, but I skipped that step, and it works just fine for me. In fact, actually, when I did it, when I saved a PNM file last time, it didn't work for me, so go ahead and skip that. Oh, and when you're saving a file in here, make sure the mesh is not named the same thing as a folder inside of the folder you're in, otherwise it's just going to go into the folder. So it is going to save that, and it won't take too long. It does take some time once in a while. Alright, now we're going to open up MeshLab and check our folder, or check our file, excuse me. And we're going to just open it up and see how many vertices there are. Okay, 400,000 vertices aren't bad. And then we're going to see if we can't just get it to render. So one thing right now to notice is I think it's not rendering properly, so if we go ahead and just go to Filters, Normals, Curvatures, and Orientation, and then just invert faces orientation and apply it, we'll be able to see the Mandelbulb itself actually. So you can actually go ahead and render this in your softwares. So as you can see, it's good, but the mesh quality isn't entirely there. So if you really want to get a better mesh quality, when you export it, make sure that you export it in a higher resolution. And then if you want to follow his tutorial, the next thing he does is he goes to remeshing and then quadratic edge collapse decimation. And if you do that, you'll take away a lot of the faces and vertices. It's like decimating in ZBrush. It's very useful. So we're going to export this as a new file and call it mesh export mesh lab. All right, and hit OK. All right, and we're going to close out MeshLab and Fiji. And we're going to open up Cinema 4D. All right, and because I have a plugin that doesn't like me, that'll pop up, and we'll go ahead and let it load. All right, so the first thing we're going to do is just import that object. So go ahead and hit Open, and go to your folder that you saved that in, and open it up. Cool. And now you have your object, and we're going to save this as a new file. So it's just going to be Mandelbulb 3D. Okay, so this has, it says 809,624 triangles. So if we go ahead and hit the points, if we check points on edit mode, we can notice that we have 403,264 points. So it's a lot less actually than I had in my other Mandelbulb, which will be useful because that'll take less time to render anyways. So the first thing we're going to do is just make a matrix object. And we're going to check object mode, or not check it. I guess we're going to go to the drop down. We're going to set it to thinking particles. Let's go ahead and make a thinking particle group. You do that by going to simulate, thinking particle settings. Right click on that. Thinking particles, by the way, are a fantastic tool if you haven't used them before. Another good tool is X particles, but I don't have X particles because I use thinking particles. So we're going to make this particle group, and we're going to call it Mandelbulb. And we are going to make it a majestic purple. No, we'll make it blue. So we'll make that the thinking particle group, and then we'll check after effectors in case we want to add any effectors to this to move anything around. And the next thing we're going to do is add the object. So we'll go ahead and drop that in. And it's going to take a little bit to load it in, but not as long. And you'll notice that you're only getting part of your fractal now. And we need to go back to our thinking particle settings and type a few extra zeros in the max particles. So once you've done that, you can go ahead and reset your frames, and I'm going to just drop the frame count down here. So in thinking particles, one thing you have to do sometimes is you have to update the timeline. You have to go back to 0 to get rid of thinking particles that you aren't using. So I've already turned off the matrix objects, so the thinking particles should be gone, but they're not. So you have to go back to frame 0. And that's just something that Cinema 4D Maxon needs to update. Also, we're going to go to the Krakatoa renderer. If you don't have this yet, go ahead and look at thinkboxsoftware.com. It's a fantastic renderer for Cinema 4D. It's a point cloud renderer, and you can pick up your copy here. I got mine from the tool farm, so pick it up wherever you'd like, and can't recommend it enough. Let's go ahead and set it to 1280 by 720. Lock the ratio. We'll save it as current frame only. And let's see. We'll go ahead and check use absorption. We'll just get this set up right now. And yeah, we'll leave it at that for now. And we're going to drop in a target light and set it to ray trace shadows and 120 for the outer angle. Okay, now let's go ahead and drop in, go to plugins and Krakatoa, and then Krakatoa TP source. Okay, and then that's just going to load all of your thinking particle groups. I'm going to check on channels ID and age and lifespan. And these are things we're going to use in a little bit. And let's also use size, mass, scale, and we'll go ahead and look at those in a bit. So let's go ahead and start by just hitting render. And the first thing we do is we get this. And this is just what comes out naturally. We're going to undock our render settings and make sure we can see these, so we can start editing it. And it looks super cool. The absorption is on, and I think it's actually absorbing the lights. So I don't know if absorption is inherited from older scenes, if it could, because I don't have blue anything set in here to my knowledge, and I'm not sure why it does that. But one thing you can fix is override, or you can check override color and override absorption, and it will inherit these colors right here. So if you want to use, say, an orange absorption color or brownish absorption color, and then check use absorption, then it will absorb and turn greenish blue. And let's go ahead and make that a little stronger so you can really tell. And we'll turn the final pass density to 2. Okay, and if we turn the overall density to 1, that'll help. And if you move it around, you'll notice that this is actually about 180 degrees off from what the color is actually going to be visibly. So if we set the value to, say, 20, that's going to be orange. But if we set it to 200, which is 180 degrees off, that blue is almost identical, if not identical, to the blues that we're getting from the absorption. So just keep that in mind. That's how absorption works. Okay, and all right, so we've got our particles set pretty well right now. We'll go ahead and just render with an orange color with a blue absorption. Actually, let's go ahead and make it a greenish absorption, because then it'll maybe a little bit more green. I want it to be orange and purple, and see how that comes across. Not really liking it, so let's keep on going and seeing what we can find. I do like that green and orange color mix, maybe with a little yellow instead. Looks very natural. Let's go ahead and swap actually over to a less organic color. Get something pink and maybe something a little blue. Maybe not that color. Okay, and again, you need to be 180 degrees off. So I'm going to pick the color I want and then subtract 180. Though I do like that green. So we'll go ahead and stick with that last color. Okay. Oh, again, yeah, we're not looking for green. My bad. Okay. So, anyways, just keep tweaking those settings to your heart's desire. And come across what you want. One other thing I like to do, actually, is we're going to type Shift-C, and then we're going to center axis 2, and then we're going to hit Reset PSR. And that will place that in the center frame, which is not something that the object will do natively. It's actually going to, let's see, the center point is actually going to be over there, and the geometry's center point isn't there. So this helps us put it in the center of the scene. So again, another way to do that is go to Mesh, Axis Center, Center Axis 2, or Axis Center Settings. And if you just hit Execute, this is what Center Axis 2 is going to take, these settings right here. So if you've changed these and it's not working, say you've changed it to -1, 100% I mean, then Center Axis 2 is going to inherit those settings. So let's go ahead and just reset PSR now. I think reset PSR is under the character commands, yes. Alright, so now we're going to go ahead and turn back on our thinking particles. And we're going to make sure we change this to dots. Okay. And there you go. So now you have your fractals already being rendered with thinking particles. And let's go ahead and take a look at our other scene. Oops. Let's see, it's this one right here. It's a big scene, by the way. This mesh is a very different scale. This one right here is the same resolution we output from the other one, but the other one has, I guess, more rounded edges. So, and because of that, it has over 2 million vertices, which makes for a lot of polygons, and it's a 238 megabyte file. So it's going to take a little bit to load in, so just keep in mind some of these can get pretty big. So let's go ahead and load in our Mandelbulb one more time. And just bear with me as this loads, and then we're going to open up Espresso so we know whether it's actually loading our Espresso setup or not. And the way I do that is I click Calculate, Performance View, and then I enable it, and then I'll set it to, like, 2 million or something like that, because it's going to get called 2 million times. And, that's time. We want let's see, that's 2,000, so 20,000, 200,000, 2 million. And we'll set it to 2,200,000. Okay, cool. So we'll go back to frame 1, and again forward to frame 0, or excuse me, back to frame 0, then forward to frame 1, and we're just going to wait until these things start to turn red. Okay, good. So they've turned red, and for some reason, okay, they didn't load all of our particles at once, but it was actually kind of cool. You could see it happening. So as we hit render, you're going to see that these particles are now rendering, well, that's cool, based off of our distance settings that we set. And we have our just our gradient color. And if we open up our render settings, you'll notice that I've changed the final pass density to 3. And it does use absorption, so it is inheriting some absorption in this right now. So we'll turn that off and see how that renders. Okay, it's actually not using absorption, but anyways, there's some, it actually looks a lot like a jellyfish. It's kind of cool. So if you're doing scientific renders and you have to do render, and it's not something you have to like render anything specific, it just has to look like a cell, a Mandelbulb Fractal will be a marvelous choice for that, I think. So we're gonna go ahead and look at this render setup. So I've just got my TP source right here, and I've got my thinking particle settings, and I've checked all of the same ones that I had in the last one, plus birth position, and random seed. But you don't really need to check any of those yet. We will go back in a bit to the other one and use size, mass, and scale, and see if we can't do something with that. I didn't prepare it, so we'll do it on the fly, and it should work. But if it doesn't, prepare it on the fly. So, and then we have on our Krakatoa TP source, we've right-clicked and gone to channel gradient, and we are using the I think it comes in as position, which by the way is really cool. If you just use position, you actually don't have to use Espresso, and it'll take care of it for you. You'll get stuff like that, and that is awesome. That's just freaking cool. But if you go to source channel name and go down to age, which we're setting in Espresso right here with the pset data node, you can see that I've used the age to set the color and the absorption values. So it'll take your source channel and, map it with a gradient vector to the destination channel, which sounds complicated, but if you just go ahead and set it, this is the input, your age, your particle age, and then you're setting it to absorption or to color. You can also set it to your velocity and things like that. So I think that only does that for the render, but who knows, maybe that'll set your age to the velocity, and that could be a cool tool you could use to set your velocity for animating particles. So something to try later. And then you're going to set your output data type to vector. Float is a single number, and vector is three numbers. So that would be RGB would be a vector, but just R itself, or the value in this case, would be just a float. So if you want to use a float value, you're not going to get colors. You're going to get gradient values of black and white. Well, actually, that's not true. I guess you will get colors, but that's the difference between a vector and a float. So I guess I don't really understand why they have that difference there. You have a gradient input from magnitude squared. You have magnitude, and this is right now using the age. If we use X, Y, or Z, I think that will be a better example if we use position. You'll notice that it'll use the X settings to render it. In this case, because of the camera angle, we're going to use Z, and it'll give you a better example. You'll look left to right, and it'll render, or a Y axis render, just a vertical axis. You'll see that the gradient's applying. So again, these look so cool, very colorful, very vibrant. If you uncheck normalize gradient input, it won't normalize the input, so it won't adapt the input based on the highest and lowest values, is what I think that means. That's what normalizing does in audio engineering. So if you uncheck that, sometimes it'll give you different results. Like this looks like something super cool. I mean, this, honestly, I really do think that looks like something you'd find in the ocean. So really cool stuff right there. So again, that's using the position. And here, we're going to try using the age again. So super cool. So let's go ahead and look at that Espresso setup, and then we'll go back to our other setup and make a new one. So what we have here is just our PPass node, and this is a node that you can find under System Operators, Thinking Particles, TP Initiator. You drag it in, and then you can set your Thinking Particle group in there. I actually think it's really funny that I made a particle group in here, and I never used it. I just used all, which is fine. Doesn't actually cause any problems, but I just think that's funny because I went to the extra effort to make a particle group and never used it. All right, the next one we use is a TP get or pget data node, and that's found under the TP helper section. So let's go ahead and open up Espresso in full screen. So you can do that by going to TP helper. If you right click and go to new node, Thinking Particles, TP helper, get data node, you can go ahead and input that particle with the particle P group from the PPass node, and you can output the position or the age or different things like that. And I can show you how to set things like earlier I did a test where I was using the life and age. I was setting those with the index of each particle, and I can show you how to do that as well. So maybe I won't. I don't want to go over too much on time. We've already hit 30 minutes. So we have our distance checker null object. It's named distance checker. We could also name it Bernard, and then it would be changed to Bernard in here. So it really depends on, you can name it whatever you like. So Bernard's going to help us out real quick. So Bernard is getting checked. So if you've ever played football and you get checked, it's not like that. You have your position of this null object right here. Let's go ahead and just take that null object and we'll make it a cube and XZ axis. So that'll let us see where it is. Okay. And then you have your thinking particles, and every single one of these little dots right here has its individual position. So if we scroll out just a bit, every one of these has a position. So we're checking the position of, so the way this works is the PPass node will go through every particle, each one at a time. And then we'll go through that particle and we'll say, hey, this particle right here has a position. We're going to compare that position to the position of our particle checker, or in this case, Bernard, with the distance node, which is found under Espresso General, I think. Actually, I think it's under Calculate Distance. Yep. And then you'll take that and you'll output it. And that output we put, in this case, into a range mapper. And again, I'm going to use the sphere for this example because it's going to give you a better example that you can see a lot quicker. So you'll see that the node right here, or excuse me, the null object right here, is now getting checked according to these particles. So there you go. So now we're getting blue particles close to that null object, and we're getting green particles further away. And that's because of this gradient right here. So if we invert the knots, you'll see that it's green by the null object and blue further away. And if we normalize the gradient, you'll see that that changes it, and we have less green. And one of the things I did is I added some user data to the TP settings. So you can see that there's the TP settings null object I dragged in right here. It's just an object node. And I dragged it in, and or drug it in, I guess. And then I I placed the life, I dragged in the life user data on top of this gray box over here to add it, and the age output upper. And those were applied to the null object. The life goes into the pset data node, which is found under TP standard set data. So I drop down, so when you drag this in, you have your particle group, and then you can get age and life, and we'll drop those down and connect particle to particle. We're going to make the range mapper. So we're going to take the distance and put that into the range mapper, which then goes into the age. And then we're going to use the age output upper to set the output upper of the range mapper. And then we're going to use the life, as the life. And actually what I should have done probably is the input upper. And that's actually what I named it first, and then I did it wrong. I named it input upper on accident, but that's what it should have been named anyways. So you'll notice that these values will, well, let's go ahead and just set this really quick. So if we hit render and we change this value to 10, set our life to 1. Let's see. So what this should do is actually, because the input upper is now 10 and the life is 1, every particle is just completely blue. It's just hit its life capacity. Okay. So, but if we go to those TP settings and set it, the age input upper to 1 and the life to 1. Actually, let's set the life to, say, 5, maybe 50. I think this is a little bit more relative to the distance that you've set. Alright, we do need it to actually run through Expresso. So let's go ahead and set that back to 5. And then we'll update it and make sure we have our particles and that the distance node says that it has been checked. Okay, we'll try one more time. We'll keep adjusting these settings, and this is something you gotta test a little bit more. It's not as much, I mean, it's an exact science, but to get the visuals pretty spot on, you need to go ahead and make sure you can actually see what's going on. So testing it a lot is gonna help. One thing I want to do is select the sphere and go ahead and subdivide it once. That's gonna give us a lot more particles, so I can get a clearer view. Okay, so what we have right now is there's green up here, and just everything else is blue. So let's go ahead and set this to 13 on the life. So again, we need to make sure all of our particles are being counted. Okay, so for some reason they're not. And that's probably because there's a lot of particles. So Cinema 4D has to set the matrix object, then the particles and all that, and it's going to keep going. So let's set it to 15 and see if that works. Alright, and then we're going to update it again and again. Frame 2 right now is what we're working with. Let's try setting it to 20 for the life. I won't spend too much longer on this, by the way. We'll go ahead and move on and actually get some... Oh! Guess we're going to move on now. We're going to go back. Anyways, those are where those settings work. So if, as you could see, if you tweak those settings, you're going to get green and blue, or technically your gradient's going to get moved around, and it'll help you figure out how to get that set. So tweaking those settings, that's just something to try out. Alright, so we're going to go back to our Mandelbulb 3D scene that we made in Mandelbulb 3D Fiji and MeshLab. And actually, because we have so many particles, or not as many particles in here, one thing we could do is we could get really adventurous and copy this. I'm a little nervous to try this, but we could try subdividing it and seeing what that gives us. Alright, so that gives us 1.5 million points. So that's actually not a bad number, so we'll go ahead and try that. And as you can see, the normals are all messed up, so we're going to just delete that normals, the normal tag, and just let Cinema 4D figure out the normals itself. And we'll rename these. We'll call this first one low res space Mandelbulb, and the next one will be high res Mandelbulb. Okay, so we're going to check on our matrix object again, and this time we're going to drag in the high res Mandelbulb. because we want more particles. Nothing we can't do without. Or something we can't do without, I guess. So now we have our render. And it looks purple, which is what we did on purpose anyways. So we're going to go ahead and try again adding the channel gradient and using position and color really quick and seeing how that affects our particles. So let's see, we don't have color set in here, or we do have it here, so that's so it's being overridden in our render settings. So now that we've added that tag and fixed that by unchecking that setting in the render settings, we're gonna go ahead and just hit render again, and it should actually work with the gradient now, as you can see. One thing I like to do sometimes is test just with a black and white gradient. Because I think it's going to look a lot cooler that way, personally. Turn off absorption and turn it on in here, but make sure it's black. And you get this almost kind of like a wireframe, so a wireframe look. So I think that would be wonderful for motion graphics renders. If you do user interface elements, something like let's go ahead and look at their site. Let's see, Krakatoa in production. So let's see if there's any user interface elements that they've used lately with Krakatoa. I don't think Oblivion used Krakatoa in the user interface. Let's see. This is all Krakatoa. This is 2. So say you're creating a user interface element and you need to make it look like a hologram. That's something you can do. Let's see. Yeah. Anyways, Krakatoa is usually used for particles and explosions and smoke and stuff like that, but you can use it again for Mandelbulbs. So let's go ahead and turn absorption back on with the scene master render settings. And actually, in this case, we're going to turn it off. Actually, we're not going to turn it off. It's not on. We're going to use position and use absorption right here. And we'll just set a gradient with absorption based on the position. And right there, guys, that's really cool. Look at that. That looks like, well, I'd say it looks really organic. And then we can go ahead and take those settings right there. And so what we did is we have our TP source and we have these gradient, our channel gradient tags. One of them is taking the position and setting it to absorption, and one of them is setting it to color. So we're going to go ahead and make sure the color is set to a black and a dark yellow. And then we're going to render it and make sure that absorption really comes out. So right now the absorption's not really coming out the way we want it to. And maybe what we need to do for that is actually have these be bright values. And we'll see if that helps. Okay, so it's not absorbing right now the way I want it to. So let's go ahead and invert these. We'll see if that works. So we'll go ahead and again turn off the channel gradient. So if you want to use just absorption, you can actually work with that quite well right here. And we're going to turn the density down on these from 1 to 0.1 and see if that will allow us to have the light travel through better. It's not, so let's, oh yep, we are overriding density there, so let's go ahead and set it to like 0.25. Turn it off in the master render settings. Okay, so it works better. But I do want it to have that harsher look, so let's go ahead and go with 0.5. So it's a great way to make something like that. So I think this is really exciting. I don't know about you, but being able to do something like this and then go ahead and set up like, let's go ahead and set up a camera with an 80mm focal length. And then let's go ahead and set a null object in the scene and call it camera controller. and drag the camera under it. Normally I would group it, but in this case I don't want to because, oops, that's too many frames. Let's go ahead and do 300 frames. That'll be 10 seconds. So a 10-second loop, I'll set it to 360. The reason I said to not group it is because if you do, it'll inherit the camera's position and rotation, and you want this to be in the center of the scene. And then you can go ahead and just rotate around the object. But you can't do that right now because the scene is slow, super slow, like painfully slow. So the way to fix that is to go into your output, and we're going to output awesome as our particle token. Okay, so we're going to save our density and our age, lifespan. Actually, we aren't going to do either of those because we don't need them. And we're going to partition it, save multiple partitions. We'll save 10 partitions, and we will randomize the position. Let's go ahead and add a cube to the scene. And just based off of what we have right now, I'm going to make this cube 1 by 1 by 1 and see if I can see it. So that's going to help us check the position, or maybe 5 by 5 by 5. That's going to give us an idea of how much those particles are going to move. So in this case, I actually think I'm going to set it to 0.5 for the jitter. For rendering or for randomizing the position, it's going to move them all in different positions, about 0.5 centimeters, or exactly 0.5, as the max value for randomizing it. All right, I'm going to set these back to their default settings just for my sanity. I think we're set. I think we are ready to output these. Okay. So we've got the absorption set, the color set. So let's go ahead and make sure we set our absorption right here, and density and color. We don't need to do velocity. These particles don't move. And we're going to need to save it in a location. So what we're going to do is we're going to go to our save section right here, and we're going to set the area. Normally you do this for rendering an image, but in this case we're actually going to use this to set the location where we need to export our particles, because that's how Krakatoa works in Cinema 4D. So PRT underscore export. So we'll save it right there. Mandelbulb underscore PRT export. Save. Okay. So we'll leave that checked. We'll uncheck multipass because we don't need it. And then we'll hit submit saving job or partitioning jobs. And because output right now was set to current frame only, it's only going to output our current frame. And then it's once that loads, it's going to put it into the render queue. It's frozen right now. I guess it's not frozen. It's just thinking. So there you go. Okay. So now it is going frame by frame by frame, loading the particles, 1.5 million, 1.6 million particles each time, saving them and moving their positions just a little bit. So it saved all of them, and it saved them on frame 0. That went way too fast. Our matrix object was turned off. Ugh, gotta do it again. So, one more time. I was really wondering why that was saving so quickly. That was just way too fast. So it's gonna, what it's doing is when you say submit saving job or partitioning job, it's going to save one file, one scene file for every partition you're going to, save. And we are saving 10 partitions, so it's going to make 10 files, and then it's going to load them in the render queue, and once it's loaded them in, then it'll open the render queue. So let's see how we're doing on time. We are at 50 minutes, so I will wrap this up shortly. We're going to go ahead and hit play. Or not play, render. That's this button right here. Unless it does it on its own. Should. So we'll let that go ahead and go, and I'll pause this while it simulates these. Alright, so it's finishing the last one, and each of those only took probably about 5 to 10 seconds, I think. So, I think the first one took a little longer. No, it just felt like it did. Okay, so we've got all of those, so we're going to turn off our Krakatoa TP source and our matrix object. And we're going to reset the 0 frame, Now we're going to load in what's called a Krakatoa, Krakatoa PRT loader. And you can find those under Krakatoa, under your settings up there. Okay, and we are going to open our particle file, and that is in here. And we'll just go ahead and click the first one. The way Krakatoa works is it will export a JPEG, and the way it writes it isn't as a JPEG. It'll export a PRT file, but it'll save as a JPEG, and then it'll later change it to a PRT file. So click on the PRT files, and hit open, and say, we have 10 partitions to load, so load 10 partitions. Okay, and then I also want, to load every nth particle by ID. And I want to load every 5th particle for these examples. So we're going to check the box, load additional partitions, so we can load all of our particles. So we are only loading 5% of our particles, and we are already almost back to what we had in the scene before. So we're going to take these. Actually, we could just go ahead and hit render for starters and see how that goes. So it's going to take a lot longer to load because we have way more particles now. And then we'll go ahead and add one more channel gradient and see what we want to do with that. So the first thing I'm going to do is set the overall density, or override density, value to 0.3. And we'll test that really quick. Take about 10 seconds to render it. So it's going to retrieve the particles, sort the particle lighting, add shadows, rendering 16 million particles. Wonderful. Alright, and I want to make my light brighter. So I'm going to make it 100 and... I'm going to try 150. That might be too much. Probably is. It's 1.5 times the light, so we'll see how that works out. Again, rendering 16 million particles, so it's a little much, so we're going to go with 130. And let's go ahead and do one thing. We're going to pull the camera out and make it a 50 millimeter lens and look at it again. Kind of decide exactly what we want to do here. So, again, that's just a little too bright. I wonder if you can... Yes, you can. Okay. Awesome. We're going to rotate this sucker. So, we're going to rotate it on the... we're going to rotate its pitch over time. 180 degrees. And we're going to rotate the... Oh, I don't know what that is. It's going to be... Is it whole? No, I don't remember. There's pitch, bank, and then there's the other value, which we're going to look up on the help value, help sign, or help menu real quick. Rotation, and see if it'll tell us. I'll look that up in my own time. Anyways, we'll rotate that 540 degrees over time. Oh, we have duplicated our object. So let's go ahead and delete the old one and just use the new one, because that's where our animated values are. And then it will rotate over time. And let's go ahead and see if... So when we go to our next frame, we actually lose our particles. So if we check use custom range, we'll keep our particles, and we can just go ahead and hit play. And what we're going to do is just we're going to uncheck all frames. So it will just go through based off of the time that it should be at, that we can kind of get a preview. And it's a little slow, but it gives us the right idea. And we're going to go ahead and start on frame 80. We're going to check, we're going to click on the high-res Mandelbulb and hit S. Okay. And then pull out just a bit. Not frame 80, sorry, the focal length we'll set to 80. And then we'll go ahead and uncheck that, and there you go. We'll go ahead and hit render in a moment with this and see how it looks over time. So one thing I want to do is add a light with a ray traced hard shadow to the center of that object and see if that'll help us kind of bring out those dark shadows. So it kind of helps. Let's go ahead and try it again without the shadows and see what happens. And you could render this with less particles, but because of the level of density that you have calculated, I wouldn't, because you won't really get the full idea of what you're going to get. So one thing I'm going to do is try making it 250. We're going to make it pink. And we'll make it purple. We'll see how that works. Alright, so you're getting results, but it's not entirely what we're looking for. So we'll just go ahead and turn that off and delete that. And then we'll go back to our options and turn our final pass density from 5 to 2 and see if that'll help us out. It will make it less dense for the particles. The particle density will actually, the light will travel through it faster, so we'll see more. So yeah, we'll get something more like that. So let's go to frame like 150 or 140. And we'll go ahead and render it. And this is just backlit right now. So we get this nice backlit view, and if you look at that, that looks fantastic. It's super cool. The only thing I'll do is just pull out a little bit again, because it's just a little tight, and go to frame 180 maybe. Do one more test render with a right view. It does get cut off up top. One other thing I am considering doing is starting in closer and then going to the last frame. And then pulling out a lot. So we'll try that. And we'll go ahead and do just a few test renders really quick, and then we'll wrap it and save it and export it. So there's that. Because it's moving, the particles technically could have a velocity. I wonder if it will give us a velocity channel. We could try. So we'll go to 200 now. See how it looks further back. By the way, Mandelbulbs fractals are super cool. It's kind of like how an L system works, if you've ever worked with L systems before. I mean, you understand what a Mandelbulb does now after watching this, but yeah, it's a lot of fun to work with. The very last thing I want to recommend we do is we'll go back to frame 1 and we'll drop one of the low-res Mandelbulbs under the PRT loader that's animated, and then do a play blast really quick. And we'll hit Option B, and we'll just do all frames, software preview, and we'll do 720 by 405, and save it as a QuickTime file. And that'll calculate a preview for us of this animated. So actually we don't even need animated preview technically, but so this is what it's going to look like in the end, except for it won't render as geometry, but even just that right there looks really sick. So if you just wanted to render that as is, well, you can't because you're not using our normal renderer, you're just using Krakatoa, but yeah, it gives you the right idea. So that gives us the right timing, and that just confirms the fact that, okay, this is the timing I'm looking for, and that is the colors I'm looking for. It's a little blown out in some spots, but frankly, it looks more realistic because of it. Nothing is perfect. The last thing I want to do is just set up, the render settings. Again, we have to render it elsewhere now, because that was the PRT export. Now we're going to call this render, and we will call it the Mandelbulb render. Then we're going to copy that and paste that, and we'll just append that with another underscore, and then in all caps we'll call it multi, and then we'll uncheck multi-layer file. Personally, I'm not a huge fan of that. I'm going to use OpenEXR on both of these. Check alpha channel. Go over here. Go to render to multi-channel EXR. I guess it's not really multi-channel. And then we'll just do file, and then we'll save file type EXR. We'll do a normal pass, velocity pass, z depth pass, and occluded particle pass. And the camera object we're going to set to the focus object to the PRT loader, so that will help with the depth. And then we'll go ahead and leave it as is for the rest of it. And hopefully, we didn't cache a velocity pass, so let's see if we can use let's go ahead and right click and just look at our settings really quick. I haven't done this before, so I don't know how this works, but let's go ahead and take our velocity and map it to our velocity and see if that will oh, here, we're gonna preview this really quick. Preview. Hopefully it will load all of the frames. I usually turn this down. Okay. So for the speed itself, pulling out right there, I might tweak the animation curves a little bit, but I think it looks good. Okay, good. So that's the timing we're going to want. And let's go ahead and just set the velocity to the color. Okay, so the velocity doesn't exist. So again, we'll just go ahead and render it out, and we'll save an EXR file with the velocity and see if it saves anything, but it might not. So we'll uncheck save and go ahead and render to the 3D picture viewer, just the current frame, and we'll let it load and render it. And then once it renders, we'll go ahead and check single pass and check some of these and see what happens, and then see if we have it. And because you're rendering an OpenEXR file, you're gonna have a different view. It's gonna be 32-bit, so it will look 32-bit. So we don't have any of those besides alpha, which is inconvenient. So, but we're good. Actually, technically, we could check depth of field, and that would probably solve our problem. And then we'll go ahead and go to Krakatoa camera under Krakatoa. When you right click, Krakatoa tags, Krakatoa camera. And then we are going to make sure that that camera now has the depth of field settings that we're going to need, because this camera's focal distance is 2,620 away. So let's go up close really quick and render, and we'll just preview it right here. So the settings in Krakatoa will normally take the distance, and it'll be set to 1,000, and we're going to want it set to a higher value at the end and a lower value at the beginning. As you can see, the depth of field is causing us to view over here, but over here is a little shallower. So let's go ahead and render again and see if this is helping us out right now. If it is in focus properly, it will render the center of the Mandelbulb, which it's doing. So looks like it's good. Yeah. Guys, that looks awesome. Alright, so let's go ahead and just check save and output all frames. We'll just leave the settings as is for the rest, and that render looks really cool. So let's go ahead and just make sure that we're right about that render looking cool by hitting render and letting it render. So go ahead and check thinkparticle.com for more tutorials. One thing we're really excited about is if we go ahead and go to our Vimeo page. Let's see. If you get on my Vimeo page, you can actually see that we've just updated the TP toolkit. So if you want to work with thinking particles in other exciting ways, there are millions of ways to use thinking particles, and you can use the TP toolkit, which is found on our website, and we've just released an update, and it has really cool things like a new item called custom turbulence. So that is something you should go check out. It's really exciting. So anyways, thank you for watching this video. I am Sam Welker from thinkparticle.com, and I will talk to you guys later.